Good afternoon, Ivan Serrano and I we are going to present our motor control system.
To carry out this challenge, we use three different software. The first is MATLAB, which helps us to model the control system and see its behavior. Then we use Arduino and Python. With both, we use ROS for decreasing the node and topic.
The nodes and topics will act as follows. The signal to motor node will publish in the setpoint topic. The controller node will read this data and will rotate the motor and publish its speed in the topic angular speed that will be read by the signal to motor node generating the loop.
In the electrical part, we use several components, like motor with encoder and gear reduction, H-bridge to regulate the current we send to the motor, an SP32 microcontroller, jumpers, resistor for a voltage divider and reduce from 5 to 3.3 volts, a LED to indicate the communication with ROS, and a USB-C power delivery supply. The first step was to identify the linear part of or operating point of the motor, in order to obtain its characteristics and generate its transfer function. Using the Ziegler and Nichols method, we obtain the first approach to the gains of our PID controller. Theoretically, the sampling frequency should be double the cutoff frequency of our motor, but in this case we quadruplicated, giving us 60 Hz as a result.
When we use the control system, we notice that it works very well in the low range, but not so well in the high range. We realize that a PID type controller that works well under all conditions doesn't exist. It may work regularly, but it will only be effective under certain conditions. Therefore, we decide to create two controllers, one for the low range and one for the high range. This will alternate according to the value required at each moment. The advantage is that the motor will be better controlled in all range. But the disadvantage is that when using several controllers, it can be confusing. We can see that we have a good control behavior thanks to the performance indices that are the maximum overshoot, rise time, set time, integral error, and peak time.
As we can see in the video, even with disturbances in the motor, it returns to the desired speed in a short time.
The sources we use to solve this challenge are knowledge and projects of the Soviet Analysis of Control System and Foundation of Robotics. Also, we use the official rules documentation in Python.
The most important conclusion that we discovered is that there isn't that perfect controller, and the performance indices are very useful for analysis also, and improve areas that we can look for a more effective controller that we can search him reducing these performance indices.